So for a set of data, you should already be aware of what the range is. This is the difference between the maximum value in the data and the minimum value. You also need to be aware of the interquartile range. This is the difference between the upper quartile and the lower quartile. Now, one of the advantages of the interquartile range over the traditional range is it's less influenced by extreme values. So for example, take this list of data here. Now, if you calculate the range is equal to the maximum value, which is 80, minus the minimum value, which is 5. So the range is 75. However, this doesn't really reflect what's actually going on in the data. This suggests the data is quite spread out. However, almost all of the data is between 20 and 36 and is quite closely packed together. It's only because of these extreme values here that makes the range a lot bigger. Compare this to the interquartile range, which is equal to 7. I'll show you how to calculate this in a moment. This is more reflective of the actual data, with a lot of the data points being quite close together. Now, you also have something called the interpercentile range, which is the difference between two percentiles. One of the most common ones is the 10th to 90th interpercentile range, which is the difference between the 10th and 90th percentile. This has the same advantage as the interquartile range, as it's less influenced by extreme values. So far in this chapter, we've talked about two things: measures of location and measures of spread. Measures of location can be split up into measures of central tendency and measures of other locations. So measures of central tendency include the mean, median, and mode. They try and tell you the central point of the data. Now, quartiles and percentiles are also measures of location, but they focus on other parts of the data, not the center. What we're talking about in this video are measures of spread. These tell you not about the location of the data, but they tell you how spread out it is, whether it's all very close together or far apart. Another measure of spread is the standard deviation, which we're going to talk about in the next video. So how do we actually calculate the interquartile range? So let's do it for the example that we talked about at the start, okay? Now, in the last video, I talked about specifically how to calculate the lower quartile and the upper quartile. So I'm not going to go in loads of detail how to do it in this video. I'd recommend going back to the last video if you need to know how to do that. Just as a reminder though, this here is how you do it. So for a list of data, we first need to find the number of data points. Okay, so for this list here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 data points. So that means n is equal to 14. So let's start with the lower quartile. So to find the lower quartile, we need to find n over 4. So we need to find 14 over 4. So this is going to be 3.5. This here is a decimal. So when it's a decimal, we need to round it up to the next whole number. So this is 4, and this is the value that we're looking for, and we can see that the fourth value is 25. So the lower quartile is equal to 25. Now let's find the upper quartile. So we need to find 3n over 4. So this is going to be 3 over 4 times 14. So this is going to be equal to 10.5. This is another decimal, so we need to round this to the next whole number, which is 11. So this is the value that we're going to find, and the 11th value we can see is 32. So the upper quartile is equal to 32. So therefore the interquartile range is equal to the upper quartile minus the lower quartile. So it's going to be 32 minus 25, which is equal to 7. So this is the interquartile range. So by far the most common exam question that they will ask for this is for you to find the interquartile range or the interpercentile range for a grouped frequency table. So here's an example of this, where we're told a delivery company delivers 78 parcels in one day, and the grouped frequency table, which is this here, shows the distribution of the parcel weights, and we need to estimate a value for the 10th to 90th interpercentile range. Okay, now to solve this we need to use interpolation. Now we talked about interpolation in the last video. If you want a detailed understanding of how it works, I would recommend going back to that video. So to do this, we need to find the 10th percentile and the 90th percentile. So when you have a grouped frequency table like this here, the first thing that you always do is you find the cumulative frequencies, so CF. So this is 30, and then 30 plus 22 is 52, and then 52 plus 15 is 67, and then 67 plus 9 is 76, and 76 plus 2 is 78. So N, the number of data points, is 78, okay? So let's start with finding the 10th percentile. So this is 10%, or 0.1. So this is what we're going to multiply n by. So we're going to do 0.1 multiplied by 78, which is equal to 7.8. So this here is the data value that we're looking for the 10th percentile. Remember that for a grouped frequency table, we don't round it like we did before with the quartiles. We just keep it as it is here. So we're trying to find the 7.8 value. So if we look at the cumulative frequencies, these are the first 30 values. So as we're looking for the 7.8 value, it's going to be in this interval here. So between 0 and 5. Okay, so if we look at this interval, so I would draw a diagram like this here to show what's going on, as I talked about in the last video. So it starts this interval at 0 kg and it ends at 5 kg. And if we look at the frequencies, this is the first interval, so it starts at 0 frequency and then it ends at 30. We're trying to find the 7.8 value, so let's say that between 0 and 30 this is about here, so this is 7.8. so this is the value that we're trying to find. Okay, so we need to find how far along this interval 7.8 is, what fraction along this interval it is. So the way that we're going to do this is we're going to do 7.8 divided by 30, which if you put this into your calculator is equal to 0.26. So this is how far 7.8 is along this line between 0 and 30, and this is going to be the same on this side of the line as well. So this interval, it starts at 0 and then it's going to be plus, so it's 0.26 along the interval, and this is going to be multiplied by the width of the interval. So it's between 0 kg and 5 kg, so the width is going to be 5 kg. So we're going to multiply 0.26 times 5, and if you put this into your calculator, this is equal to 1.3 kg. So this is the 10th percentile. Okay, so now we need to find the 90th percentile. So this is 90%, or 0.9. So this is what we're going to multiply n by. So it's 0.9 multiplied by 78, which if we put this into our calculator is equal to 70.2. So this is the value that we're trying to find. So if we look at the cumulative frequencies, these are the first 30 data points, these are the first 52, these are the first 67, and these are the first 76, and we're trying to find 70.2. So it's going to be in this interval here between 15 and 20. So if we look at our diagram here, so this interval starts at 15 kg and ends at 20 kg, and this cumulative frequency, it starts at 67 and it ends at 76, and we're looking for 70.2. so let's say this is about here. So this is the value that we're trying to find. Now, as I talked about in the last video, we need this 67 to be 0. So from all of these frequencies here, we're going to minus 67. So this 67 will just become 0. And then this 76, if you minus 67, will be 9. And then this 70.2, if you minus 67, this is equal to 3.2. So this here is now going to be 3.2. Now we need to know how far across this line 3.2 is, between 0 and 9. So we're going to do 3.2 divided by 9, which if you put into your calculator to 3 decimal places is 0.356. So this here is how far across this line 3.2 is. So it's going to be the same on this side as well. So this interval starts at 15 kg and then it's going to be plus, so this is how far across the line it is, and then we're going to multiply it by the width of the interval, which is between 15 and 20, so therefore it's going to be 5. And if you put this into your calculator, it's equal to 16.78 kg. So this is the 90th percentile. Okay, so the 90th percentile is 16.78 and the 10th percentile is 1.3. So the 10th to 90th interpercentile range is going to be P90 minus P10. So this is going to be 16.78 minus 1.3, and this is equal to 15.48 kg. So this is the final answer.